Hey guys, today we're talking about power functions and function operations. So, our goal is to perform operations with functions and analyze the domain. So, operations, you know what these are: addition, subtraction, multiplication, and division. So, addition, also known as the sum, okay, we're going to find the sum of f and g, so we add them together. Subtraction, we call the difference. Okay, because we're going to find the difference. H here is the difference between f and g. Multiplication we call the product. Okay, so H is the product of f and g. And division is the quotient. Okay, f divided by g. So now you'll notice that I have this g can't be 0 because g is in the denominator. And are you allowed to divide by 0? No, you are not. So your denominator can never be 0, and we're going to get more into that when we see any fractions ahead of us. So keep that in mind. Okay, so let f of x equals 4x to the 1/3, and g of x is 8x to the 1/2. Okay, so we're going to perform the indicated operation and then state the domain. So the first thing I need to do is find the domain of each given function, because really I combine them most of the time in my answer. So here I have an odd root. So you have to ask yourself, are you allowed to take the odd root of anything? And the answer is yes. Okay, this cube root, right, this is the same as 4 cube root x, is allowed to be anything. There's no restrictions on a cube root. So the domain is all real numbers. The difference between 8 square root x is that you can't take the square root of a negative number. Okay, so you basically always start with all real numbers, and we have two exceptions. Okay, one exception is when you have an even root. Okay, you have to be greater than or equal to 0. So x is greater than or equal to 0. Okay, 0 is okay, but if I plugged in a negative number here, it would be undefined. So I'm going to first find f plus g. So I have 4x to the 1/3 plus 8x to the 1/2. And I always use parentheses because there are specific times where you need them and it makes a difference. So I always use them. So what I'm really doing is multiplying both of these by 1. Since there's only one term in each of these, they don't really, in this scenario, need parentheses because I'm really just multiplying by a positive 1, right? So then you have to ask yourself, okay, can I add those together? So is x to the 1/3 and x squared like terms? They are not because they don't have the same exponent. So I cannot put them together, and that's my final answer. Okay, so it's then my domain. Oops, I almost forgot. Domain. Well, basically I have to combine both of these. So they both are all real numbers, and then I have to include that x has to be greater than or equal to 0. Basically, I'm putting them together. Okay, so then I do f minus g. So 4x to the 1/3 minus 8x to the 1/2. Now, again, these aren't like terms, so I cannot put them together. So then my domain, again, is all real numbers. X is greater than or equal to 0. Okay, because I'm basically combining both of the domains of my original function. Okay, so now I have f times g, so 4x to the 1/3 times 8x to the 1/2. Alright, so what's 4 times 8? Well, we're at 32. And now I'm multiplying this x to the 1/3 and x to the 1/2. They have the same base, so my base stays the same as x. And then since I'm multiplying, I have to add the exponents. 1/3 plus 1/2 is 5/6. Alright, now my domain, I have all real numbers. X is greater than or equal to 0. Okay, and this goes for both of my originals, and this is an even root too. So even if your originals didn't have this, you would have to include it because this now has an even root. So you still have to pay attention to your final answer because sometimes that might change your domain. Okay, so now I have f divided by g. So 4x to the 1/3 over 8x to the 1/2. 4 divided by 8 is 1/2. And then now I have x's on top and bottom. And 1/2 is bigger than 1/3, so my x's are going to stay on the bottom. And then I have to subtract by exponents, right? When I divide, I subtract. And that gets me 1/6. So 1 over 2x to the 1/6. And then I have my domain. So here's where we have to be careful. Now I have this fraction. And if you remember from above and from previous lessons, that your denominator can't be 0. So 2x to the 1/6 cannot equal 0. So if I solve for x, the only way for that to happen, right, divide by 2, raise both sides to the 6th power, x can't be 0. So now I have to combine all real numbers, x is greater than or equal to 0, and x can't be 0, all into one domain. Okay, and the way I'm going to do that is I'm going to write it like this. All real numbers, and x is greater than 0. Okay, because it still has to be positive because of this even root. But it can't be 0 because it's in this fraction. So because I made a fraction with f and g, I have to take the denominator into account. And instead of writing all real numbers, x is greater than or equal to 0, x can't equal 0, I don't do that. I take this line away. Okay? So that's where that comes from. All right. Now let's go to example 2. I'm going to need you to change this question for me. H of x is x to the 3rd plus x squared minus 5. And j of x is x minus 7. And we're going to perform the indicated operation. So I'm going to find the sum first. I'm going to add them together. So x to the 3rd plus x squared minus 5 plus x minus 7. Oh, and you know what I forgot to do is find my domain first, right? We're going to do that first for every problem. Okay, so you can finish writing that down, but then we're going to go back to domain. So remember, it's basically all reals, but we have 2 exceptions. Okay, even root means x has to be greater than or equal to 0, or a fraction means that the denominator can't equal 0. Okay, so I don't have an even root in either of these. I don't have a fraction in either of these. So then I know it's just all real numbers. Okay, the even root would be like x to the 1/2, x to the 1/4, something like that. But that doesn't exist here. And I don't have any fractions, so my domain is all real numbers. Okay. So now let's add them. So again, I just have a positive 1 in front of each of these. So x to the 3rd plus x squared minus 5 plus x minus 7. And I'm going to combine my like terms. So x to the 3rd plus x squared plus x minus 12 for the sum. And my domain is all real numbers. Okay, because again, I don't have either of those exceptions. So now let's do h minus j. So x to the 3rd plus x squared minus 5 minus x minus 7. So that's x to the 3rd plus x squared minus 5. I'm going to distribute this negative. So minus x plus 7. When I combine my like terms, which I don't really have very many, just this negative 5 and 7, I get a plus 2. Okay, x to the 3rd plus x squared minus x plus 2. And my domain is all real numbers. Moving on to the product, and again, make sure you're pausing if you need extra time to write some stuff down. So h is x to the 3rd plus x squared minus 5, and j is x minus 7. So again, you can distribute. There's multiple ways we can multiply this, so you'll just kind of have to decide which way makes you happier. I like the rectangle, so I have x minus 7, x to the 3rd, x squared minus 5. Okay, you can also do your distributing, whatever makes you happy and is going to get you the right answer. So x to the 3rd times x is x to the 4th. X squared times x is x to the 3rd. Then I have negative 5x. Negative 7x to the 3rd. Negative 7x squared. And 35. Then I combine like terms. So I have x to the 4th. My only like term here is negative 7x to the 3rd and 1x to the 3rd. I add those together, get negative 6x to the 3rd. minus 7x squared minus 5x, plus 35. And my domain, again, all real numbers, because I'm just combining the original domains. All right, then I have h minus g, or h divided by g, x to the third plus x squared minus 5 divided by x minus 7. I can't simplify that, so that's it. It's pretty easy. Now we have to think about the domain. So now I've created this fraction. So when you create a fraction, you have to understand that the denominator can't be 0. So x minus 7 can't be 0, which means x can't be positive 7. So now I have all real numbers except 7. Okay, so you got to be on the lookout because sometimes these exceptions, and again there are 2, will show up later when they weren't in the original function. Okay, so I hope you found this super educational, and make sure you're writing down any questions that you have. Write down in the margin so you're ready to ask them when we see each other next. See you then.